In the last video, we covered alkyl, alkene, alkyne, benzyl, and phenyl groups. In this video, we will move on to our next functional group. Alkyl halides can also be called haloalkanes, but for these videos, we'll be using the term alkyl halide. As a simple definition, an alkyl halide is a compound in which a halogen has replaced a hydrogen atom of an alkane. As a reminder, halogens are any element in group 7 of the periodic table. In organic chemistry, we will often see fluorine, chlorine, bromine, and iodine. This functional group is easy to recognize. If you remember your halogen elements, you can detect an alkyl halide very quickly. We sometimes represent alkyl halides as Rx. But what if you have a halogen attached to an alkene, alkyne, or aromatic compound? Well, it's almost the same, just a slightly different name. An alkenyl halide is when a halogen is bound to an alkene carbon. An alkenyl halide is when a halogen is bound to an alkene carbon. An aryl halide is when a halogen is bound to an aromatic ring. Pretty simple. Alcohols are compounds containing a hydroxyl group bonded to an sp3 hybridized carbon. You hopefully remember that a hydroxyl is OH-. Well, when the hydroxyl oxygen is bonded to anything else, it becomes neutrally charged. The second part of the definition is extremely important. The carbon that has the hydroxyl group must be sp3 hybridized. In other words, the carbon must have exclusively single bonds. We often represent alcohols as ROH. In bond-line formulas, we often don't show the bond from oxygen to hydrogen. Maybe since this group is so common, drawing that bond would be tedious. To expand, if we have a hydroxyl group bonded to an sp2 hybridized carbon, such as a benzene ring or an alkene, it is no longer an alcohol. Instead, they're phenol and enol groups, respectively. You may not be required to know these two groups this early in the course, so I suggest clarifying with your professor. As we go along discussing group after group, it's easy to get confused. As we continue, I'll try to give little tricks to remembering the different types of functional groups you may come across. Ethers are simple. You have an oxygen connected to two alkyl chains, or at least one carbon on each side. Ethers can come in different shapes and sizes, and you'll often see them written as R-O-R. You can see ethers in straight chain forms or even cyclic ethers. No matter what, they're still the same functional group. However, it's important to check what is attached to the carbon directly attached to the oxygen. The only substituents can be hydrogens. If any other element is attached to the carbon part of the ether, it's now a different functional group. We'll get into a specific example of a different functional group in a later video. When specifying ethers, you need to make sure to circle the oxygen and the carbons directly attached to the oxygen. Also, it's important to remember that since oxygen has two lone pairs, ethers are drawn in the zigzag pattern. This is because the lone pairs will push apart the bonds on either side. This video hopefully shows you that functional groups aren't all that scary. There may be a good amount of them, but understanding each and then being able to identify each is not much of a challenge.